Okay, so we got a boat that travels 9 miles per hour in still water, right? So one big thing from our chapter this week is direct and indirect relationships. Distance varies directly with time when a rate is a constant, right? Or you could rework this equation too. You could solve for time. Like we could say T equals D divided by R, or one other way we could say R equals D divided by T. Just algebraically tried to, get all the letters by themselves. This is the same equation, just rewritten in 3 different ways. All right, so let's see which one of those is going to help us here. In still water, the boat travels at an average of 9 miles per hour. The current is going to help it when it's going downstream, right? The current is going to slow down that 9 miles per hour when it's going upstream. So let's see. So let's make 2 equations. Let's make an equation for the time takes us to travel the 26 miles downstream, right? So we want to know time. How long does it take us? It tells us that it takes us the same amount of time to travel 26 miles downstream as it does take us to travel 10 miles upstream. So at some point, t is going to equal t in another equation. Basically, we're using this one here. The time equals the distance divided by the rate. So the time it takes us to travel 26 miles downstream, we don't know, but we know we can plug in 26 in for the distance. And then the rate is going to be 9. And since we're going 26 miles downstream, I'm going to add a variable c. That's the speed of the current, okay? Because if you're going downstream, you're going your normal 9 miles an hour in still water, plus a certain miles per hour to help us with the current. And then we can make another similar equation. The time it takes us to travel 10 miles upstream. So time equals 10 miles over 9 minus c, right? In this case, the current is working against us, so we should be less than our still water speed. That's why I subtracted 9 by c. And now we're told that the 2 times are equal to each other, right? It takes the same amount of time. This t equals this t. So to finish solving this equation, you just set these 2 things equal to each other. Right, so 26 over 9 plus c equals 10 over 9 minus c. And now we've got a rational equation to solve. Okay. So when there's 2 ratios like this, when there's 2 fractions that equal each other, there's a quick trick, and you can do all the algebra a couple of times to see it happen. Multiply both sides by 9 minus c. What you can do is when there's 2 fractions equal to each other, multiply the diagonals. So I'm doing 26 times 9 minus c, because they're diagonal from each other. And that equals, oops, need my pen back. That equals 10 times 9 plus c. Just multiply it across the diagonals, right? And now if you distribute that 26 times 9 makes 234. Minus 26c, that equals 90 plus 10c. Just making some room for myself. Okay, and then now we've got a plain old regular equation. We want to get c by itself, so I'm going to add 26c to both sides. That'll make it disappear on the left side. That way we just have to solve it on the right side. So I get 234 equals 90 plus 36c. So subtract 90 from both sides. Get 144 equals 36c. Then we got to divide both sides by 36. So So we get C equals 4. That's the speed of the current. So that's 4. And then we're talking about miles per hour, our units, right? You wouldn't say a speed of a current is miles, right? Because a speed is talking about change of distance over time. So this is all in miles per hour, so our final answer is in miles per hour.